All right. So next up, tangent and cotangent. Out of all the graphs, tangent and cotangent are kind of the weird ones. They don't act quite the same as the other four. So we are going to talk about these a little bit more. After sine and cosine, all of the rest we've seen, they have places where they're undefined. So that means their graphs have vertical asymptotes. We should know what that is from college algebra, but just in case you forgot, remember an asymptote is a line that we are approaching without actually crossing. So when we evaluate a trig function and it comes up undefined, that means there is a vertical asymptote on our graph. So let's figure out what the graph of tangent looks like. So we'll go to our handout where we have all of our graphs. You'll notice I picked some weird points here and a few more points than I put on sine and cosine. We won't do this many every time we graph it, but I put all of these on there so we could get a better idea of what the graph looked like. Because I felt like if I just did 4 or 5 points, it wasn't really clear what was happening. So let's start, I'm going to start at 0. What is the tangent of 0? 0. Okay, pi over 4 is like 45 degrees. So tangent of 45, radical 2 over radical 2 is 1. Tangent of 90, radical 4 over radical 0. Okay, 3 pi over 4, that's the same as pi over 4, but it's in quadrant 2. So tangent is negative there. All right, pi, that's the same as 0. So tangent of pi, 0. Okay, you'll notice I didn't keep going to 2 pi. I'll explain why in a minute. I went the negative direction. So negative pi over 4. That's the same thing as 7 pi over 4, right? So it's just in quadrant 4. Is tangent positive or negative in quadrant 4? Negative, and it would be the same as the tangent of positive pi over 4, so we get negative 1. At negative pi over 2, that's the same as 3 pi over 2. What's tangent going to be? Negative 3 pi over 4. That's the same as 5 pi over 4. That's in quadrant 3. In quadrant 3, tangent is positive, so that's positive 1. And negative pi and positive pi are the same place, so that's a 0. All right, so my points here. We have negative pi. We're going to have to add in a couple more tick marks. I added more points on the table and forgot to adjust my graph. So at negative pi, my graph is 0. 3 pi over 4, it's 1. At negative pi over 2, my graph is undefined. That means it's an asymptote. Negative pi over 4 is negative 1. 0, 0. Pi over 4, 1. Pi over 2, get an asymptote. 3 pi over 4. It's negative 1. Pi is 0. We know something from college algebra. Asymptotes, we are approaching these lines, right? So when I draw this, it's curved. It's getting closer to my asymptote. If I draw these curves approaching our asymptotes, how many periods of tangent did I just graph? We'll have like the upward piece, the downward piece, and then I repeated, didn't I? I have an upward and a downward. Tangent repeats faster than sine and cosine. Sine and cosine don't start repeating themselves until you go all the way around the circle, 2 pi. But if you think about tangent, it's positive in quadrant 1, negative in quadrant 2. What happens in quadrant 3? Positive. Quadrant 4 is negative. So tangent repeats after a distance of pi. Halfway around the circle, and then it's just repeating itself. So the normal period for tangent is shorter than sine and cosine. When we graph this, we are going to graph one complete cycle. So you could go 0 to pi. I like to graph mine from negative pi over 2 to positive pi over 2, because that way I don't have an asymptote in the middle. I just have one complete piece. So tangent, when we graph this, I will do the interval every time, just because it's kind of weird. We're not going to start at 0. So I go from negative pi over 2 to positive pi over 2. Basically, that's like the first and fourth quadrant. So we have a positive and a negative. And then our graph is one nice smooth curve, asymptotes at the ends. So we won't do all of these points when we're graphing it. We're just looking at basically these will be enough for us to get that entire graph. We could answer questions about domain and range. Probably not what I'm really going to ask you. I threw it on here just as a discussion. Domain, this graph doesn't exist everywhere. Where does it not exist? Pi over 2, negative pi over 2. Would that be the end of it, or would there be more? It would be all those multiples of pi over 2, right? You could put that as like pi over 2k, where k is an integer. Do you remember seeing that before? This is just a notation. It just says k is an integer. It's just another way of saying all those multiples of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, or the negatives. We're going to have asymptotes there. The range, where do the y values exist? Everywhere. Negative infinity to positive infinity. All right. We also talked about even and odd with sine and cosine. Let's do that here. Is tangent even or odd? If I reflect it over the y-axis, does it overlap itself? No. So this is an odd function, which means if you have a negative on your angle, it comes out in front. What was the other odd function we've seen so far? Sine or cosine? Which one was odd? Sine was odd. Remember, cosine was the same on both sides, so it was the even one. All right. Let's talk about cotangent. All right, cotangent of 0. So square root, it's like tangent flipped, so it's radical 4 over radical 0. Undefined. Tangent of 45 degrees, or pi over 4, is 1, so cotangent is 1. At pi over 2, that would be like radical 0 over radical 4, so we get 3 pi over 4. That's in quadrant 2, so we would get a negative 1. Pi is going to be the same as 0, which is undefined. 5 pi over 4, that's in quadrant 3. And quadrant 3 is cotangent positive or negative? Positive, so we're back to positive 1. 3 pi over 2, 0. 7 pi over 4, that's quadrant 4, so cotangent would be negative 1. 2 pi is the same as 0. Okay, so I'm going to have to add in a few more points here. So tangent or cotangent of 0 was undefined. So that means vertical asymptote. Pi over 4, we get 1. Pi over 2 is 0. 3 pi over 4, negative 1. Pi is undefined, so asymptote. 5 pi over 4 is 1. 3 pi over 2 is 0. 7 pi over 4, negative 1. 2 pi is undefined. So we know this graph is just getting closer to these asymptotes. How many complete cycles did I just graph? 2. Because again, like tangent, it only has a period of pi. It starts repeating itself when you get to that third quadrant. So if we're graphing one period, we're only going to have to go from 0 to pi. And that would give us one nice piece. Again, I picked the weird intervals. Cotangent, we go 0 to pi. Tangent, we do negative pi over 2 to positive pi over 2. So that the asymptotes will just be at the ends of our graph, and we have one nice smooth curve in the middle. The domain of this one, what can x not be this time? 0, pi, 2 pi, and it would go on 3 pi, 4 pi. So it just basically can't be any multiple of pi. Or you could write this where k is an integer value. Again, range, what do we get? All right, even or odd. If I drew this on the other side of the axis, my pattern is just going to continue. Is it the same if I reflect it over the y, or is it opposite? It's opposite. So cotangent is again odd. So the only even function we have so far is cosine. And remember, that means that if it has a negative on the angle, you can just drop it. All right, any questions about these graphs? So, for graphing them, we're going to do the same things we were doing with sine and cosine. Amplitudes, periods, and count by. We are going to, I might also add in, we'll do the interval every time too, because I think that makes it a little bit easier. Then we know the asymptotes go at the end, so we'll draw in our asymptotes and zeros and sketch our final graph from there. Y equals the tangent of 2/3 x. The amplitude, the number out in front, is just 1. All right, period. This is something that's different than sine and cosine. Sine and cosine, we always did 2 pi divided by the number in front of x, because 2 pi was how long it took before those graphs repeated. How long does it take for tangent and cotangent to repeat?
Just pi.
Just pi. So we do pi divided by the number in front of x. So we get 3 pi over 2. The count by, we're still just going to take our period divided by 4 to get those nice points on our graph. So that gives me 3 pi over 8. I recommend doing an interval on all of these. All right, the section that we graphed, that's not the only section that exists, but we're picking a nice one. So for tangent, what was the nice interval I said we were going to use? Negative pi over 2 to positive pi over 2. So just like we did with sine and cosine, you start with the beginning, you put your angle in the middle, and then our ending. So we're going to do negative pi over 2, less than or equal to 2/3 x, less than or equal to pi over 2. So if I'm trying to get x by itself, what would I do? So I get negative 3 pi less than or equal to x less than or equal, How about negative 3 pi over 4? Less than or equal to x, less than or equal to positive 3 pi over 4. So because we're not just starting at 0, your period can move your starting point. So if I'm graphing tangent, my first point is negative 3 pi over 4. Okay, if I add my count by plus 3 over 8, so we've talked about using a calculator, or you can think negative 6 over 8 plus 3 over 8 is negative 3 over 8. So negative 3 pi over 8. Plus 3 pi over 8 is 0. Plus 3 pi over 8. Plus 3 pi over 8, 6 pi over 8, or 3 pi over 4. So again, we have 5 total points, just like before. We pick this interval so that we know automatically both ends are asymptotes. And both tangent and cotangent will have asymptotes at the ends and 0 in the middle. All right, so now the question just is, do we go up or down? So just think about it. This is like quadrant 4 and quadrant 1. Tangent is negative in quadrant 4 and positive in quadrant 1, right? So it should be increasing. Amplitude, it's not really a true amplitude here, but we use that to get an exact point. That's where we're going to be at these points. So at negative 3 pi over 8, we're at negative 1. Positive 3 pi over 8, we're at positive 1. Then when you're drawing it, it is curved. So make sure it looks curved. Don't draw a straight line. And it should look something like that at the end. A little bit different, but a lot of the same stuff. Do you guys have any questions there? Let's just keep practicing. What's my amplitude? 1/2. What do I do about the negative? Okay, period. Normal period for tangent and cotangent is? That's not good. Yeah, just pi divided by the number in front of x, so we get pi over 2. Count by, we take our period, pi over 2, divided by 4 for the 4 quadrants, and we get, it's like pi over 2 times 1 over 4, so pi over 8. Interval. Tangent goes between what numbers? I'm going to put the angle in the middle. So if we divide by 2, or multiply by 1/2, so negative pi over 4, less than or equal to x, less than or equal to positive pi over 4. Alright, so my first point will be at negative pi over 4. If I add pi over 8, negative 1/4 plus 1/8, negative pi over 8, plus pi over 8 is 0, plus pi over 8 is pi over 8, plus pi over 8 is 2 pi over 8, or pi over 4. Amplitude is 1/2. So we pick this interval because what happens at both ends? And what happens in the middle? Tangent. Which direction does tangent go? It's increasing, right? But I'm flipping this. So that means at negative pi over 8, I will be at positive 1/2. At positive pi over 8, I would be at negative 1/2. And if we ever got confused, how do we verify what the value is at these points? Yeah. You could think about your different quadrants and positive and negatives. You can plug them back into the original function and evaluate them. Lots of options there. Try this one. What's my amplitude? Okay, normal period for tangent and cotangent is pi divided by the number in front of x. So pi divided by 1/2. Count by is always period divided by the 4 quadrants. So pi over 2. Interval, this is different, it's cotangent. What nice interval do we use for cotangent? 0 to pi. So if we multiply by 2, we get 0 less than or equal to x less than or equal to 2 pi. So my interval is starting at 0. If I add pi over 2, we have pi over 2. 2 pi over 2 is pi. 3 pi over 2, 4 pi over 2 is 2 pi. Amplitude of 3. What happens at both ends? And at my middle point, it should be 0. Okay, now we're graphing cotangent. Is cotangent increasing or decreasing? Decreasing. Think like this is, our first point is representing quadrant 1, and it's positive in quadrant 1. So here we would be at the positive 3, at 3 pi over 2, I'd be at my negative 3. All right, so those are all pretty straightforward examples. We've also done with sine and cosine, we talked about moving our graph left and right, up and down. So we have those same transformations with tangent and cotangent. Let's look at an example of each of those and then I'll be done. What does that minus 3 do to my graph? Then what's my amplitude? Period? Now 5 pi over 4. Interval, we always set tangent up between negative pi over 2 and positive pi over 2. So, my first point happens at negative pi over 2. Add pi over 4, so we get negative pi over 4. Add pi over 4, we get 0. Pi over 4, pi over 2. And that's where we said our interval should end. How did we handle the down 3? Yeah, we went to -3 and we drew in a dashed line. It's not really a horizontal asymptote, we're just saying this is the center of my graph. Okay. Tangent has asymptotes at both ends. In the middle, we're at 0, but our 0 point is at -3 this time. Okay, tangent, remember, is increasing. This is like coming from the negative and going to the positive. So at -π/4, I'd be at -4. Positive π/4, I'd be at -2. Now this time I did ask for 2 periods. How do I make this 2 periods? 4 more points. We just keep adding our count by. So 3π/4, pi, 5π/4, 6π/2. Sorry, 6π/4, so 3π/2. Okay, asymptotes on both ends. 0 in the middle. Starts down and goes up. Is that okay? What's our amplitude? Period. Count by. Interval. It's cotangent, so we do cotangent between okay, so if we subtract our π/2, left from -π/2 to positive π/2. What does the 3 in front do? So -π/2 plus π/4 is -π/4. Plus π/4 is 0. π/4, π/2. We are moving up 3. We know both ends are asymptotes. And the middle is 0, which will happen on this line. Now, does cotangent increase or decrease? Decrease. So at -π/4, I'll be up 1. At π/4, I'll be down 1. did ask for 2 periods, so we need 4 more points. So just keep adding our pi over 4. Cross into it at the end, 0 in the middle, and the pattern continues, it's just decreasing. How are these going? So, here's my plan. The homework, section 4.3, it's on that same document we've been working. I am going to give you probably half the class tomorrow to work on it. So the first half of class you can work on it. Second half, I want to start talking about secant and cosecant, and then we'll finish secant and cosecant the next day. So I'm basically spending 1.5 class periods on these. So this homework won't be due until today's Wednesday, right? So it'll be due Friday. And you will have about a half class period tomorrow to work on.